So with this, पुण्यश्लोक अहिल्या देवळकर, Solapur University, Solapur, M.Tech Mechanical Design Engineering. The syllabus of theory and analysis of composite material. Inside the first chapter is introduction to composite material, which contains the definition of composite material, then classification of composite material, then types of matrix material, then types of reinforcements. What is meant by matrix, what is meant by reinforcement, and then composites, then characteristics of matrix material, reinforcement material, as well as characteristics of composite materials also. Then selection of proper matrix and proper reinforcement material which will be suitable for any particular application. Then what is meant by fiber composites, what is meant by laminated composites, what is meant by metal matrix composites, what is meant by particulate composites, what is meaning of prepegs, pre-pregnated, impregnated, or what is prepegs, and then application of composite material. So this short part in the introduction of the composite material that we have to learn, and starting with this we will study the fundamental part of this. So in general, if we think about the composite material, then basically we will have to first of all study the origin of all the materials. So if we study the different ages, we know that Iron Age, Bronze Age, Stone Age, like these different ages were there in ancient histories if we try to see. So whenever the persons where man was not social and different ages were there in the development phase of human being, the different ages were considered. So in Stone Age, the material most probably used was the stone material. Then in Bronze Age, human beings started to use the bronze material, then iron material, etc. But still, this is very ancient days, because we know that Ashok Stamba is there, and in that Ashok Stamba was before Christ 300 years. So all of we know that this is very different kind of material used in the Ashok Stamba, because near about 2300 years has been happened. So this material is not corroded up till now. Still, we can observe this material which is present in Delhi, this Ashok Stamp, and this is the different identity of India. So Indian culture regarding this material is very strong, and many invention at that time was also happened related with the material, because this bronze material was first of all invented in India and that was started to use. The Indian history about the material science and engineering is very good, and many literature is available in the materials also, if anybody is interested to carry out the research in material science and engineering. And if you want to take the reference of the old things or ancient things, then Rasa Ratnakar Shastra, like this Granth is available, and many Rushis at that time was making the innovations related with the materials, and outcome was that the material which was generated, so that materials was the evidence like Ashok Stamba. This is one of the evidence. So basically the material is only single material. If we go for the Mendel's this periodic table, so the Mendel's periodic table gives the information about all the materials inside that. If we start from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, like this, all metals are present inside that, all non-metals are present, heavy elements are present, radioactive elements are present, like this. All the elements that was classified, and that was the given first of all the periodic table. But if we try to identify the different, then metals are different, non-metals are different, ceramics are different. So all these materials have their own identity. As far as concerned with the metals are conductive, then non-metals are not conductive. Likewise, one different category is there, that is polymer and ceramic. Means if material like this we try to study, then inside the material, basically these are the three types of materials, out of which first is the polymer, second one is the metal, and third one is ceramic. Is it okay? So polymers are the materials which has ingredients like, if we see the different materials like HDP, LDP, low density polyethylene, high density polyethylene, polyoxymethylene, polytetrafluoroethylene, nylon, and PVC, polyvinyl chloride. So all these categories, these materials which are inside the category of the polymer. So in case of composite material, the three domains are largely in the discussion worldwide, out of which the first domain is considered to be polymer matrix composite. The second large domain is considered to be metal matrix composite, and third large domain is considered to be ceramic matrix composites. So as per the application of these composite materials, these are designed. Suppose I want to go for the material which is very hard and tough material, then in that case my ingredients will be different. I have flexibility to choose the matrix and reinforcement material, because whatever the new material I am going to manufacture, that has these ingredients. So from this concept of the composite, the that ingredients and the design of material, that concept came into existence. Means what? Means if I am interested for one particular kind of category of the properties, then I will get the advantage of matrix as well as reinforced material from that point of view, in order to enhance the particular property. Suppose I am interested in tensile strength, my material design will be different. If I am interested in compression strength, my material design will be different. If I want tough material, then my design or ingredients will be different. If I want it as corrosive resistance, wear resistant material, then that way also the ingredients and my way of material design will be different. So with this concept of composite material, one more domain came into existence, and that domain is called as the material design. Is it okay? So material design is the one big domain through which now whatever the materials required for various industries, that industries may be marine industries, sporting industries, then automotive industries, aerospace industries. So for all these kind of industries, the materials, always any technology has requirement of new materials. The innovations and inventions in the materials, that will never die, because always technology looks for the new material. And by keeping that things into mind, this different domain for which there is a large scope and requirement for the technology, because energy and material, these are the two fields always in which the research never dies. Always there is a requirement of new materials for the technology, and always there is a requirement of energy from different energy resources for the technology, because cheap material and cheap energy, if it is available, then that can be used by the human beings with affordable price, and much amount of abundant amount of this materials as well as energy will get available, because every human being uses that two things, and that's why there is always scope for working in the material science and engineering. So now, as far as concerned with these materials, as we were talking about the only metals, or we can say that, suppose aluminum is there, then copper is there, ferrous is there. So these are the only monolithic materials, metals, only metal. The one area was there where only metals were there in existence and that were used. But later on, alloys were started to use. So what is the alloy? Alloy is to add this certain content inside this metals. Suppose aluminium, inside that silicon is added, then this will become the A356 alloy. Is it okay? This is one simple example. Likewise, if we add the copper, if we add the manganese, if we add the magnesium, if we add the zinc, if we add some another constituents like this silicon, etc., then the properties of the material will change. Addition of zinc will have different properties, addition of silicon will have different properties. So in which property I am interested, based on that alloy will be selected for the different applications. So suppose there are 7 series inside the aluminum, series 1, series 2, series 3, like this up to series 7. Then each and every series are differently identified as per its application, because the properties of the material changes, and based on that properties, this category of the material is always identified separately. Is it okay? So the first thing which is identified as a part of this material is the basic or matrix material. Is it okay? So metals and alloys, these are can be considered as matrix material in case of metals. So polymer, metal and ceramic, these three can be considered as matrix material. So for the composite, if we try to define this particular thing, what is composite, then composite is a structural material that consists of two or more combined constituents that are combined at a microscopic level and are not suitable in each other. We say here these are not soluble in each other. One constituent is reinforcing phase, and which is embedded is called as the matrix. The reinforcing phase material may be in the form of fibers, particles, flakes. The matrix phase materials are generally continuous. Now the example of composite material includes concrete reinforced with steel and epoxy reinforced with graphite fiber. Is it okay? So try to understand the concept of composite. So first of all, we are considering composite material as structural material. Is it okay? And it consists of not only two but more than two also. The three phases may be possible. So it consists of two or more combined constituents, so that are combined at macroscopic level. Is it okay? Macroscopic and microscopic, these are two different levels. Microscopic levels means, suppose alloy, if magnesium is added in small 0.02%, etc., then that is totally miscible inside the domain metal. Is it okay? Suppose we are adding some small zinc inside the aluminium. 99% aluminium is present and 0.2% zinc is present. Then zinc will be regarded in that case as the small ingredient, or we may say this as the alloying element in case of this aluminium. So in that case, whatever the alloy get generated, that alloy is having the phase as a continuous phase, and there is no any kind of heterogeneous form inside the material. Now I am particularly using the word heterogeneous because in case of composite materials, the two phases are always separate from each other and these are not soluble each other. In case of alloy, it doesn't happen. In case of alloy, one particular alloying element, when added inside the parent material, then whatever added material inside the parent material that get dissolved inside the parent material, and whatever the properties we will get, that will be different properties than only metal, but whatever the dissolved material, so that doesn't remain in heterogeneous form, but that gets soluble, that get completely miscible inside the parent material. It doesn't forms any kind of different phases. Matrix is different, reinforcement, like these different phases are not formed in case of alloy, and that's why the alloys are different from the composites. In case of alloys, parent material and alloying material, both materials are means will not form any third phase. So added material will be the part of this parent material, and this will get totally dissolved inside the material, and whatever the properties we will get, so that properties will be different. But in microstructural level, if we observe inside the microscope, we will get the single phase, no more than one phases will be observed there. But in case of composite material, if we try to observe in the microscope, then definitely we will be able to identify the matrix as a different and reinforcement as a different. Is it okay? So suppose carbon fiber is present, glass fiber is present, etc. Then that fibers will be considered, are considered to be a reinforcing material, and that reinforcing material which are present, that will be regarded, that will be distinguished, that will be differentiated from the matrix material. And that's why here purposefully we are using the word that two constituting elements are combined at macroscopic level but not at microscopic level. Alloy is formed at microscopic level, but composite is formed at macroscopic level. So it will be available at macroscope but not microscope. Is it okay? So both the phases, that matrix or reinforcement, that are not soluble inside the each other. So reinforcement is not soluble inside the matrix. Reinforcement remain as it is. If we cut that material and if we try to observe under the microscope, definitely you will get that this is the different phase and this is regarded as reinforcement material, and this is the different phase and which is regarded as matrix material. So these two phases remains as it is. They doesn't have solubility inside each other, and that's why here purposefully while defining the composite material, we says that composite is the structural material that consists of two or more combined constituents that are combined at macroscopic level and are not soluble inside each other. Is it okay? Now definitely there we will have to consider the two phases are different than one phase. Already we have defined that one constituent is called as reinforcing phase, and one which is in which that reinforcing phase is embedded is called as matrix phase. Is it okay? Inside the matrix, that reinforcement phase is embedded, so that's why the reinforcing phase material may be in the form of fibers, particles or flakes. Is it okay? And the matrix phase material is generally continuous type. Is it okay? So continuous type, so based on that we are considering the different matrix as polymer matrix, metal matrix and ceramic matrix. So these are the continuous types. In general, the simple example, if you want to study about the composite material, then in case of construction materials, if we see the bar is used, is it okay? So iron bar is used, that iron bar, but around that whatever the material is poured, inside that again sand is present, cement is present, then some coarse substances are present. Is it okay? So in Marathi we call as walu, cement and khadi. Is it okay? So cement is present, sand is present and coarse agreement is present, and all these are mixed together, then that is also one kind of composite material. and again that we are pouring around the bars of the iron. So finally whatever the pillar gets constructed or whatever the beam gets constructed, that consists of iron as well as the constructing material. So combine, if we look that, then that is also one kind of composite material. Is it okay? What is the part of which material? Which material bears which load? What is the role of matrix? What is the role of reinforcement? That we are going to see. Because whenever the composite material is loaded, either what is the role of matrix, what is the role of reinforcement, that part is also important. So that we will see. And that's why whatever the concrete reinforced with steel and epoxy reinforced with graphite, that is the examples of this composite material. Is it okay? In natural, as our curiosity, our curiosity. So in nature also there are naturally available composite materials. Now, what is naturally available composite material that we see? Say, if we take the example of wood, then lignin is present inside the wood. Lignin is present, and that lignin inside which the cellulose fibers and bones are present. Means lignin their work as a matrix material inside the wood. Lignin works as a matrix material, and cellulose fibers and bones, that works as a reinforcement material. In case of wood, if we check, lignin as a matrix and cellulose as a fiber. And in case of bones, if we see, then bone salt plates made of calcium and phosphate ions, so that reinforce soft collagen. So collagen is present as a matrix material, and calcium and phosphate ions, so that becomes as a reinforcement in case of bone. So naturally available composites inside that, wood and bone, these are two examples. Is it okay? So as far as concerned with wood, lignin and cellulose. So lignin works as matrix, cellulose works as a fiber. And in case of bones, here we consider as collagen is considered to be matrix, and calcium and phosphate ions, that is considered to be a reinforcement material. Is it okay? Then advanced composite. So that is also the interest, because in this subject we are going to learn the what is meant by matrix, what is reinforcement, what is the composite, etc. But advanced composite material, that is also one area of interest, because work is going on in different advanced composite materials, and traditionally these composite materials are used in the aerospace industries. The composites that have high performance reinforcement of a thin diameter in matrix material, such as epoxy, aluminium, examples of graphite epoxy, Kevlar epoxy, boron aluminum composites. So these are the examples of the advanced composite materials, and that are used in the aerospace industries. Is it okay? So we should study the one by one all types of these composite materials. Combining two or materials together to make a composite is more work than just using traditional monolithic metals. What word we are using? See here, it is monolithic metals. For any metal we are considering as monolithic. Suppose only aluminum is there, then that will be considered as monolithic. If we consider as a ferrous, that is also monolithic metal. If we consider copper, this is monolithic metal. So combining two or more materials together to make a composite is more work than just using traditional monolithic metals. So advantages of composite over metal, that is also one of the area of interest. So what is the advantage of this particular material. So we may consider it as monolithic. Generally, we are using monolithic material. But besides this, if we are using alloy or a composite, then monolithic metals and their alloys cannot always meet the demands of today's advanced technologies. Only by combining several materials can one meet the performance of requirements. For example, trusses and benches used in satellite need to be dimensionally stable in space during temperature between minus 160 degrees centigrade to 93.3 degrees centigrade. See, we are taking one example that what is the advantage of composite, why we study the composite material, or what is the added advantage of the composite material as compared to monolithic material, why preferences are given to the composite material. So for that purpose, one case we will study, one example we will take, and according to that example we will try to understand the importance of the composite material. See, the trusses and benches used in satellite. Is it okay? Satellites. Now this is very common thing which is happening near about in 1980. This was just into introduction, and our first satellite that was in the phase to launch. So we know that PSLV, GSLV, these are the concepts, and through that PSLV or GSLV concepts, that launching vehicles, so satellites were launched. So inside this satellite, whatever the change in temperature, so that change in temperature is existing from minus 160 degrees centigrade to plus 93.3 degrees centigrade. Is it okay? So see what change in that temperature is happening. But for that purpose, if we try to use the monoclinic material, monolithic material, so monolithic material has coefficient of expansion or coefficient of contraction. Here we always use alpha term. Is it okay? In thermal stresses also, in analysis of mechanical element, when we were studying, at that time we were used the word that is thermal stresses. So all of we know that how these thermal stresses are calculated, and for that purpose, so this alpha, that is coefficient of thermal expansion, that term is always used. If any material is restricted, if any material is there, and if it is restricted on both sides, and if temperature is given to that material, then definitely it starts to expand. When material starts to expand, and if it is restricted, if the expansion is restricted from all sides, then stresses start to generate inside the material. So coefficient of thermal expansion is one of the terms which is always considered while calculating the things. So for minus 160 degree to 93.3 degree in that particular zone, if material gets contracted or if material gets expanded, then definitely that is not useful, that is not suitable for that particular applications. So if besides this, any new material is prepared, if a new material is manufactured, then that material will be useful in order to have the properties of whatever the expected properties of this material, but at the same time it will be flexible, it will not have the higher coefficient of thermal expansions, and this will work because what happens, as coefficient of thermal expansions are high, then these materials get expanded or this material gets contracted, and that will have not dimensional stability. Is it okay? But in case of composite material, if we'll see, then there is large dimensional stability, and that dimensional stability becomes one kind of advantage in of composite material. Is it okay? So this is one example which we are taking into consideration in order to have the distinguishing properties of the composite material as compared to matrix material or as compared to reinforcement material or as compared to monolithic metals. Is it okay? So as compared to monolithic metals like aluminum, like iron, like copper, etc. If anybody choose the material design system and if anybody goes for manufacturing a new material which is having different applications as different areas, then that will have the more advantage from material design point of view. Is it okay? So as far as concerned with this composite material, we have seen the definition of the composite material. Now let us go for the part of classification of the composite material. So if we go for the classification of the composite material, we will come to know that the composite materials are classified based on two ways. So out of which the first way of classification is the classification based on the matrix material, and second way of classification is the classification based on the reinforcement material. So if we take the first example, if we take the first type of classification, then based on the matrix material. So as name suggests, which kind of matrix material is used, based on that the materials are classified. So already now we were discussing about the polymer. So if that different polymers are used as a matrix material, definitely that is considered to be polymer matrix composites. Now if we take the example of doors, now many locations UPVC doors are available. So that UPVC door is the example of composite material. Is it okay? If we try to understand the ingredients of these UPVC doors, then you will come to know that this is one example of composite material. Is it okay? Then second type, when besides polymer, if metals and metal alloys are used as a matrix material, then we consider this as a metal matrix composites. Is it okay? So whatever the naturally available materials inside that, if we take example of aluminum, copper, iron, etc., or their alloys, aluminum alloys are there, steel is there, etc., then that is considered, or that ingredients which are present inside that. So if that matrix is used as a material, then we will consider this as a metal matrix composite. Is it okay? And the third category is the ceramic reinforced ceramic matrix composite. In that ceramic matrix composite, ceramic is used as a matrix material. Is it okay? So see, for each and every type of material, there are their own advantages and limitations. Now, if we take an example of polymer matrix composite, then if suppose this particular polymer which is present, if we want this material for higher temperatures, then we can't use. So maximum polymers get melt near about 300 degrees centigrade. So polymer matrix composites can be used for the temperature range which are less than 300 degrees centigrade to 50 degrees centigrade. Is it okay? This is limitation of polymer matrix composite, but advantage is that the processing of polymer matrix composite is quite easy, because as the melting temperature of the polymer is lesser, so that's why these materials can be processed. And if we take the example of carbon fiber reinforced, now the inside that polymer also two kind of polymers we consider, out of which one is a thermoset and second one is a thermoplast. Is it okay? So thermoset is the type of category inside which they get set, and reuse of that is not possible. But in thermoplast, what happens? Whenever the plast, we can reuse them. Is it okay? So if this material can be reused, we consider the category of thermoplast. If they cannot be reused, then we consider this as thermoset. Is it okay? So thermoset are the materials, like suppose we take the example of epoxy. Now epoxy is the thermoset. If we are using LDP, HDP, etc., then these are again the different categories. If suppose PVC we are using polyvinyl chloride, then these are also polymer matrix composites. So thermoset and thermoplast. Is it okay? So if we are using carbon fiber or glass fiber along with the epoxy, then kind of material which get manufactured, we may consider this as polymer matrix composites, and inside that polymer is the epoxy, and whatever the reinforcement we are using, carbon or glass fiber, so that reinforcement inside that will work as a different phase, second phase. So thermoplast and thermoset are the matrix materials, and reinforcement. Now inside the polymer, which kind of reinforcement we use? So polymer inside which metal can be used as a reinforcement, and polymer inside which ceramic also can be used as a reinforcement. Is it okay? So polymer matrix composite, these are the category. Then, if we consider the second category, then that the second category, metals and alloys that we are using. So for that, the temperature range of metal matrix composite is certain higher. So metal matrix composites can be used for certain high temperature than polymer matrix composite. The processing is comparatively different than polymer matrix, because polymer matrix composite processing is very quite easy. But in case of metal matrix composite, that becomes somewhat complicated because the temperature ranges of metals are very high. If we take the example of aluminum, then aluminum get melted at near about 650 degrees centigrade. Aluminum and aluminum alloys, 600 to 650 degrees centigrade near about aluminum and aluminum alloys get melted. So for that, processing temperature is at that particular range. Means we can use this material up to this range. But if we use the different material like copper, iron, etc., then they will get the advantage of that way, because definitely that materials are having the temperature ranges as per their melting points, and that can be used. These materials can be used as a what we can say as a stable material in that particular temperature range. Is it okay? So based on the automotive application, etc., these materials can be used there. Is it okay? So this is one of the advantage of that kind of materials. Then third categories we are considering as ceramic matrix composite. So what is ceramic matrix composite? So ceramic matrix composite is the type of category of the material in which what happens, the temperature ranges are very high. Because if we take the example of different ceramics, what is basically what is ceramics? So carbide, boride, nitrides, oxides, all these are considered to be ceramics. Is it okay? Carbides, borides, nitrides, oxides, all these are considered to be ceramic. So when that ceramic is used as a matrix material, then these materials are considered to be a ceramic matrix material. But processing of ceramic matrix composites is very difficult. If you take the example of ceramics, if the temperature range more than 1700 degrees centigrade, above which the melting points of the ceramics are observed, and that's why the processing of the ceramic matrix composite is very difficult. But advantage is that the materials are corrosion resistance, ceramic matrix, polymer and ceramic. For that, advantage is that they will get the advantage of corrosion resistance. Is it okay? In case of metal, corrosion will happen, but in case of ceramic, the corrosion is advantage for that. Is it okay? Again, in case of ceramic matrix composite, if we try to check the stability of the material inside, that we will get one more advantage, that hardness of ceramic materials is also quite good. But material ceramics are tough. It are hard, but they are not tough. Toughness is the limitation of this ceramic matrix composites. Is it okay? So this particular classification is the classification based on the, what we can say, this is the classification based on the type of matrix material. Is it okay? What kind of matrix material we are using, based on that these are classified. And the second way of classification is based on the reinforcement material. So which kind of reinforcement material we are using? That is one question. And another, what is the size of reinforcement? Based on that, these are classified again. Suppose size of the composite material is particle size, then we consider this as particulate metal matrix composite. If the size is small about more than that, then we consider this as short fiber type of composite. If we are using more than that, there are whisker type of composites, long fiber type of composites, monofilament type of composites, laminated type of composites. But kind of reinforcement which we use, size of reinforcement which we use, based on that, again that composite materials are classified as particulate metal matrix composite, short fiber, whisker, long fiber, monofilament, and laminated type of composite material. And these are the different ways of classification of the composite material. So what kind of ingredients are present, what type of ingredient is present, based on that the properties of these composite materials will be decided, that are mm, by taking into consideration the type, size, and properties of the matrix and reinforcement material, the properties of composite materials are decided. So that's why this is one of the field which we consider as the material design. Is it okay? So for today's lecture, introductory part of this, here we will stop. Anybody any doubts about this? Anybody any doubt? Okay. Okay, very good. So give your roll numbers. Roll number 1, 2,
Yes,
3.
sir.
Ganesh, your roll number?
One.
1. Roll number 2, 3, 4, 5.
Yes, sir.
Roll number 6, 7,
Yes, sir.
8, 9, 10, 11, 12,
Yes, sir.
13,
Yes, sir.
14, 15,
Sir, 13 is last.
13 is last. Okay, very good. 1, 2, 3, 4, 5. Okay. So with this, today we will stop for this lecture. So if anybody is any doubt, then we will remain, or we will